Manipulating equations. In this section we're going to take a whole series of equations, algebraic equations, and we're going to twist one into the other. And we're going to just show how often this is required on your course. So here's a typical question. For the following expression, A over B is C over D, express A in terms of B, C, and D. So in this situation, your focus of attention is on A. You want A to be on the left-hand side. A is on the left-hand side, and that's pretty okay. But it also has a B on the left-hand side, which you're not really mad about. So the B on the left-hand side, you say, is dividing. As a divider, what's the opposite of division? Multiplication. So you now say, if I multiply both sides by the one on the bottom, I'll get B times A over B is B times C over D. Why did I multiply by B? Just for this reason. Because it would get rid of the one on the bottom. So I now have BA over B. They're going to cancel. And I'm going to get A is BC over D. I don't really care how ugly the right-hand side is. I was just asked to find A in terms of the other. That question is done. Straightforward as that. So just express A in terms of, so A is on the left-hand side in terms of the other. So if I know the three others, B, C, and D, I have my answer. Now, here's the same question, the same formula, but the focus is different. A over B is C over D. For the following expression, express D in terms of A, B, and C. In this situation, I want to know about D. I have the other three numbers, but I want D. So the first thing I say is, well, I better do something about that D. D is on the bottom, and there are different approaches, but they're all lead to the same place. We don't have to do them in particular order. But D is on the bottom. Don't like that. I'm going to multiply by D on both sides. So multiplying by D on both sides, I get D times A over B, which is the first one, is D times C over D. And that's okay. dA over B, multiplying in, is dC over D. So they're going to cancel. And I get dA over B is C. Well, it's not really much better, but at least D is on the left-hand side, and it's on the top, which is okay. So I'm going to continue with that. This is what I was left with from the previous slide. dA over B is C. But now, I don't like B on the bottom particularly. That's a divider. So I'm going to multiply by B on both sides. So B times dA over B is B times C. And the reason I did that was to get rid of the B on the bottom. Now I've got dA as BC. Well, this isn't too bad. D is on the left-hand side. It's on the top. But it's also multiplied by A, which isn't great. So I'm going to divide by A on both sides. dA over A is BC over A. And the reason I chose that is they're going to cancel. So D is now BC over A. I've got D on the left-hand side. It's on the top. It's on its own. I finished it. So D is now BC over A. There's an alternative approach that you have used regularly, which is called cross multiplication, where you say A over B is C over D. If this is true, you can say, you can cross multiply like this. You can say the top left multiplied by the bottom right is equal to the top right multiplied by the bottom left. So you can say A times D is C over B. That would have been easier in the second case. For us to get D that way, all I'd have to do is divide by A, the multiplier, which is there, and I'd get D is CB over A, which is the same answer as I got the last time. BC or CB, they're the same. So there are ways of doing that. You're used to the cross multiply, and you're used to the step-by-step elimination of various things. Now let's step up the complexity just a little, and we'll say express A in terms of B, C, D, and E for the following expression. Now you've got a slightly longer, more complex equation like this. But you know you can do this because you know it's just addition, subtraction, multiplication, or whatever, one by one step substitution. The most important thing you've got to do is you say, what are we looking at? Oh, we're expressing A. We want A on the left. So I don't like this C over D thing. That's a plus. All of that is a plus. So if I took that from both sides, if I took a C over D from both sides, well, they'd cancel. The A over B plus C over D minus C over D. And then obviously if I put one in on this side, I've got to do it on the other side. So they cancel, and I get A over B is E minus C over D. It's a bit better. I've got A on the left-hand side, and I have a B though. I don't like the B on the bottom. It's dividing. So I say A over B is E minus that. If I multiply both sides by B, because I'm only interested in A, remember, and that's dividing. So I multiply both sides. B times this is B times all of it. The B's are going to cancel, and I get A is B times this. I can leave the answer like that. It's fully done. Or if I wanted, I could multiply in BE, BC over D. And I've done it. And probably the last one in this rearranging on this particular expression is the same expression again. A over B, C over D is E, but now I'm interested in finding D. So how do I get D? Well, I say, well, it's on the bottom, which I don't like, and it's also on this side I don't like. That A over B I'm not really gone on, so I'm going to subtract the A over B on both sides. So A over B from this side, A over B on this side, and I'm left with C over D is E minus A over B, which is okay. The D is on the bottom though, so I'm going to multiply both sides by D. D times this is D times that, which is good. They're going to cancel. So C is equal to D, E minus whatever. Now, this isn't too bad. It's a bit simpler, but I've got a problem. D is on the right-hand side. And if somebody says to you that X is 2, you can also say 2 is X. So if C is this is also equal to C. So you can turn it around by saying, well, I'll flip it. So I'm going to take the C is equal to D into this, to the next slide, but in doing so, I'm going to say D this time is equal to C. So that's it there. So I'm a bit happier. D is on the left-hand side. It's on top, but it's multiplied by something. If I divide by all of that mess, it looks ugly. It looks ugly, but it cancels. So D is this. We're now going to turn to typical exam formats of this, where they say C is 8A minus 5B over 2D. Find B in terms of A, C, and D. Your focus always is to find what they're looking for, find B in terms of the other. So you're looking for B in this equation. So that's the equation, and you need B. B is on the top, but we're dividing by 2D. So I would suggest probably getting rid of this 2D on the bottom would be a good starting point. So multiplying both sides by 2D, 2DC is 2D all of this. You're left with 2DC is 8A minus 5B. Not bad. You're still focusing on B now. Or 2CD, sometimes we write the first letter. If they're in alphabetical order, it's usual for us to write them as 2CD rather than 2DC. But it's the same thing. is 8a minus 5b. I'm going to add 5b to both sides. Plus 5b, I don't like the minus 5b, or plus 5b on this side. Another way of doing that, we say, is take it over to the other side and it changes sign. But 2cd plus 5b is 8a, minus 5b plus 5b, or 2cd plus 5b is 8a. So if we look at this equation here, it said 2cd is 8a minus 5b. We would be used to taking the 5b to the other side, changing the sign, and writing it like this. Now, subtracting 2cd from both sides, we're left with just 5b. Our focus was b. If we know 5 times b is something, we just divide by 5, and we get b is equal to this. This example is important, the next one, because you're given a lot of formulae in your tables that you really say, that's fine, I don't have to remember them because they're in the tables and that's fine. But the reality is, it's very, very unusual in your exam for them to actually ask you to use the formula in the form that it's given. For example, in this question here, the volume of a sphere is given by V is equal to 4 over 3 pi r cubed. You'll find it very hard to find a question that asks, if the radius of a sphere is 10 centimeters, find the volume. That's very rare. So they never really ask you to use the formula in its proper form or in its original form. They're more likely to say, if the volume is 100 meter cubed, find the radius. So, in other words, what they say is, they say, here's an equation in your tables that you can bring into the exam that said V is 4 over 3 pi r cubed. But in the exam, they're going to say, find R given that you know V. In other words, find an expression for R in terms of V. I want you from 4 over 3 pi r cubed equals V to find an expression that tells you what's R equal to. So how do we do that? Well, the first thing we say is, well, R is not great because it's on the right-hand side, so we may just flip it. So 4 over 3 pi r cubed is V. Because if V is this, we can say it's also equal to V. So we can write the equation like that. Now at least r cubed is on the left-hand side. 4 over 3, dividing by 3, don't like. I'm going to multiply by 3. So 3 times it is 3 times it. And that gets rid of this. Now I've got 4 pi r cubed is 3v. Well, 4 pi r cubed is okay, but I'd prefer if it was just one of them. So if I divide by 4 on both sides, they'll cancel. Pi r cubed is this. And what's pi? A number. What's it doing here? Multiplying. So pi times this is this. It's there as a multiplier. To get rid of it, I just divide by pi. Divide by pi on both sides, 1 over pi. The pi's cancel. That pi will cancel with this. So I get r cubed is 3v over 4 pi. That's not bad. I've got r on the left-hand side. I've got an expression, but it's a cube. How do you get rid of a cube? What unlocks a cube? The cubic root. So if I take the cubic root of this side and the cubic root of this side, it will get rid of that r cubed for me. So the cubic root of r cubed is r. So it's that. Why would they ask that? They would ask that because in the exam, they would say the volume is known. So let's say the volume is 10,000 meter cubed. You plug in 10,000, multiply by 3, divide by 4 pi, take the cubic root, that gives you R. Your question is done.